I don't want you to learn this box right over here. I don't want you to learn it, but I've just written out these techniques so you guys know what I'm talking about. So you've seen stuff like identities, you've seen stuff like power properties, where you could take some power in the denominator to the numerator, or you can convert a square root to a power, stuff like that. And then you have some properties that go like this, where you can basically have something that's like 3 divided by 2x, and you can split it into 3 by 2 times 1 by x, right? So simple stuff like that, nothing too fancy. And I have some integrals over here, and I'm gonna see how I can use some of these algebraic techniques to basically convert these integrals, right? These are complex integrals. These are complex integrals. I'm going to use my algebraic techniques to basically convert these into the general integrals that I know, so that I can go ahead and solve these out. So let's get into it, and I basically have the first integral, which looks something like this. And how can we actually go ahead and apply this thing out? I have this square over here. I have 2 terms inside this, so I know what to do, because I have a whole square. I can call this term an a, I can call that term a b, or I can call this a b and that an a. It doesn't really matter. I know it has a whole square on top of it, so I can apply an identity over here. So let's see what happens. This is going to basically become x to the power 4 plus 1. The square of 1 is going to be 1, so just going to write 1 over there, plus 2ab. So 2 times x squared times 1. That's going to be 2x squared. Okay, now this already looks way simpler. Now I can just go ahead and multiply this x inside this bracket and basically get 3 different terms, and then I can split the integral and basically apply the power rule. So basically this is going to look something like x raised to the power 5 plus x plus 2x to the power 3. And now I know I can split this integral into 3 parts. So it's going to be something like this, something like this, and something like this. And I can go ahead and apply the power rule on these things. I know this 2 is a constant, so I can pop that outside the integral, and I'm going to be left with an integral x raised to the power 3 dx, and I can just go ahead and solve that. So all you got to do is now apply this thing, and you'll be able to solve this integral out. Now I have the second integral, which looks something like this, and I basically want to simplify this thing. So what can I do? Well, if you look at this thing, I know it can be simplified in 2 ways. So I can either basically write this thing as this, okay, and I can also go ahead and do this, where I know this has an x squared, this has an x, so what if I factor out the x terms? And so that's basically going to look something like this. And now what I can do is I can basically go ahead and cancel out the x's, so that x goes with that x, and over here I can cancel out this x with that, and I can cancel out this thing with that. So basically either way I'm going to be left with this thing, 9x plus 1 dx. Now I know I can split this integral into 2 parts, and then I can go ahead and apply the power rule on this. So our third integral is basically 3 times x divided by 2 times square root x. Okay, now let's go ahead and simplify this. So first of all, I can kind of see that I can take this 3 divided by 2 outside of the integral, because it's a coefficient or it's a constant, whatever you want to call it. So if you can just write this as 3 divided by 2 times x divided by square root x, you can see both of these things are the same thing. And now it's more clear to observe that this right here is actually a constant term or a coefficient. So I can go ahead and take that outside of the integral, and so that is going to basically look something like this. And now I know that this square root x, I know what it means. I know that this basically means this thing. And so I know that I can take this to the numerator, and that's basically going to turn into something like this. So this x has a power of 1, and it's going to be multiplied with another x, but it's going to be minus 1 by 2 dx. Okay, so if you have the same bases, you can see this is an x, this is an x. So the base is the same, and they're being multiplied. So what's going to happen to the powers? Well, the powers are going to be added. So what happens when you add 1 and negative 1 by 2? Well, you get 1 by 2. So this thing is basically going to become x raised to the power 1 by 2, and then I can apply the power rule on this, and I can solve it like that.